See. I think today I might try to set up GoLand again. I've been recommended it now for a little bit. And we'll see if it works. Yeah, last time we were having... Wait, oh. I don't know if we should do this. Well, we'll save this file. Is there... Let's do quick start. I don't really just like running things. I'd much rather... Let's see if... Do I... Oh, this is on my... Wait. What is it find? I get so confused. Search. See if it has GoLand here. That would have been convenient. All right, well we downloaded it anyways. Let's go ahead and see what's in this folder. No. All right, are there instructions? Install Linux. Tar text. All right, unpack the distribution. Okay. This kind of seems gross. Ugh. Oops. There is no... I feel like there should be a JetBrains. They don't have like an installer or package manager themselves? I guess maybe not. We could check apt. Let's go GoLand. That doesn't look like anything we want. Let's get rid of this. All right. Let's see. Is there not a Linux install? I really don't want to do it that way. Also, does it do Goland SSH? No, not Golang. Goland SSH coding. If it doesn't do that, it doesn't even really matter. I don't think it does. Okay, so this is useless anyways. All right. So, because we don't actually have this code, some of the code we do on our local machine, but this code isn't actually on our local machine, so it wouldn't help us. Not at all. All right, so one thing that we needed to clean up for this PR here. The one thing that we messed up, well, not really. This is redundant. I was going to do just data. I think it's fine because it's under apply. So yeah, we'll just call this the data interface. Then we're gonna have to update that, but yeah. It's just some cleanup that we left straggling. We had to get the kind of the proof of concept out. Now we need to clean it up a bit. All right. There's gonna be one other place, not here. Where was that? Maybe here? Yeah. Maybe we change this from phases to just let it be apply. No, we'll leave it as phases. The reason it's phases is that it's the phases for apply. So I think that makes sense to leave it. All right. So if we leave that, then this should be good. I think so. I think that's a major change there. And now if we run hack, what is it called? Verify. Oh, come on. Golent. This will take a while, but We can run this now. And that should pass because we were failing because it was redundant. Thought it could be redundant. All right, while that is running, what I wanted to go through and do now was just make sure that the upgrade logic stayed the same and makes sense. We kind of rushed through making the proof of concept. It seemed to pass the test, so that's good. If we had such good unit tests, or really their integration tests that test the upgrade, I would just leave it at that. But the upgrade of a Kubernetes cluster is kind of hard to test really well. So the biggest thing was we pulled out this here. And let's see. So all of that used to happen here. And I'm pretty sure we accidentally still double pull. So we have this here where we pre-pull the Docker images, and I'm pretty sure we double pull. I was looking at it because I'm pretty sure. Yeah, we're still pulling. So this basically does nothing because it will go and try pulling them, and then it will be like, oh, they're already up to date. But yeah, this code should be removed. Let's make sure we have it all. There's the log message. Pre-pulling. All right, so this can all just be deleted. Oh, wait, this is in our. Let's go here. So we can delete all of this. Perfect. This, I think, can actually be run before the pre-flight checks. It was kind of run in the middle of them. Which doesn't really make sense, but the interactive session is not part of the pre-flight checks. Correct. Neither is the printing the config. All right. So at this point, the major things that were done is we moved the pre-flight stuff into its own function here. And we broke out obtaining the data, this here, and using the data here. So where we get the data. All right, this all looks correct to me. Well, as soon as the GoLint runs and finishes, we'll make a build, and then we'll run tests using Kinder. Ooh, we should go ahead and upgrade Kinder and start getting that ready. No, not Kubernetes. I want to copy and paste their command right here. Okay. And I hit Control C. Like a boss. No. There we go. GoLint takes forever. I think it's because they have their own GoLint files. So I'm honestly not entirely sure why it takes as long as it does. All right, so kinder -h. No, I want version. That's what I wanted. Kind. Ooh, that's pretty far behind kind, isn't it? I think they do the exact same thing. I just wanted to verify. And no, they don't. Let's see. We don't want to use brew. All right. Make build. All right. Make build. I really find when a modern language cool. So let's go ahead and build this then. when a modern language has to use make, makes me a little bit sad. Just a little sad. All right, let's see what kind version we have now. Okay. Not as far behind as I was thinking it was going to be. Really only one version, one minor version, because this is in alpha, so that's not too bad. We'll just use kinder. As soon as that finishes building, we got to remember exactly what steps we got to take here. I'm never good at this. All right. That's running. Uh-oh. Uh-oh. Oh, come on. Ow. Ow. So we need to build a image. So kinder build node image. Oh wait, do we want node variant now? No. All right, so if we're building a node variant, we need init. We need to with upgrade artifacts. So wait, can we do node variant? We're gonna do image. Uh, 17 to 18. 17 to 18, that's what we're gonna call this image. And we're going to do with k8s. And this is going to be home go source k8s Kubernetes. Output Dockerize bin Linux go AMD 64 k8s. Easy peasy. All right, so then we're going to do, what's our base image? We need to do a base image. Base image. Maybe we needed to build a base image. I think that's fine. But we really... We need to... What is the latest? What is k8s base latest? I don't know. That's still running. Let's look and see if we can't find it. Doesn't node. We need k8s base. So it can be a k8s base or a k8s node. And the default is base latest. Okay. I forgot this really doesn't give any overview or anything. This is the date. 2020 0109. So we can go here. Cool. That built. Let's open up a new terminal. Ugh. We need to clean up this at some point. All right, I guess we need, wait, can we just do, I thought there was an images, oh, volumes. That will help us a little. All right, so we'll get a base image pooled, and we'll use that base image. That's no problem. Then what else do we need? Once we have a base image, we need to do with upgrade artifacts. So our base image needs to be a 117 image. So I guess that's the other problem. Is this a 117 image? I don't really know. There's not much put on here. I wish the... Oh, you know what? We shouldn't be doing the base because I don't think the base has... Okay, I was looking at this wrong. The base, I think, is just like the base OS. I think Node is where the OS, the versions of Kubernetes get layered on. All right, yes. So this is better. Let's check this out. So for some reason, my internet gets real crappy when doing stuff with Docker. Actually, for a matter of fact, when we go to do this, I'll my stream will drop because I'm not sure why yet, honestly. I think it has something to do with upload. I don't have the best upload here. My download's pretty good. Um, but again, when downloading images, I don't think it shouldn't take that much upload, but I guess it must. I need to look into it because it seriously sucks. And this isn't running on my machine, so it shouldn't be anything with my machine. The machine that's streaming is separate. So all right, so we have a k8s node 117 from. We need a 118, right? 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 I don't know. Man, testing upgrade is so much worse than anything else. Usually you just do it with the init artifacts, and it's pretty simple and straightforward. All right, so we have the Keybadium. Let me pull up. I had some instructions written down at one point. Let me pull those back up. A guy from upstream graciously gave me some instructions, and they worked once. And now, all right, yeah. So those instructions were first build node variant with init artifacts 115 or whatever. Okay, one second. This is the first step he says to do. So we're gonna delete this. What I had. Wait. All right. We're gonna delete all of this garbage. He says to do this. First build node variant. Obviously this would be kinder. Build node variant with init artifacts. So we want init artifacts of 117. With a base image. So our base image is going to be, let's go find one. We want a base image of should this be a base image? I feel like it should actually just be a base image, not a node image. Well, let's give it a base image. Let's try it with a base image. I think this is where I haven't tried it with a base image for a little while. Oh, no, that's not where I needed to be. Let's just do it with the latest base image. Uh-oh. Okay. So, and then we're going to name this base 117. We're just going to, yeah, I don't know, V117. We'll try that. And all Kinder is doing right now is downloading. all the computation is on a separate computer. I mean, sure, it's actually making the computer work, but next time I need to monitor the networking while it's going. Because something it does just takes my internet and destroys it. I haven't quite figured out what it is yet. All right. All right, so we should have a 117. Yep. There we go. Now, the next step to this is this. The next step is this command right here. So we're building another node variant with Kubernetes path to your binary. Okay, this is where we're going to put our binary. Home, Merrick, go, source, k8s, Kubernetes. Output, Dockerized. Bin, Linux, KubeADM. Base image. And this is going to be our Clavin X B117. And the image we want to build is, you know, I don't get here, but I don't think it's going to work. Oh. I think we screwed up. I don't see how this could work. Because we built this image based off of 117. And we really need to upgrade from 116 to 117. So no matter whether 116 or 117 KubeADM is here, this doesn't really matter. I do not know. Let me think here. All right, so we'll call this something 17, and it will have our KubeADM on it. Unknown flag with KubeADM binary. Oh, they did change it. It's not that anymore. It's it is with KubeADM, not with KubeADM binary. All right, but the real issue is our first one right here. This one. We want with init artifacts of 117. And we want a base image of 118. So we actually want the node image. Not base. Node. Do they have a 17 or a 118 node image? I don't know if they do or not. 116, 12, 13, 14, 15, 17. No 118. So we can only test upgrade from 116 to 117. That should be fine. All right, so let's find a 116 image. 116.3 is the latest. So with this one, we want to do with init artifacts from 116.3. And we'll call it V116 V117. So we'll have the 116 artifacts, and we will use, let's pull that image number. We'll use 117. This one. There later 117 release new. And we'll use a 117 image to build that on. All right. Kinder build, no variant with init artifacts of 116.3 base image, kindness node image. All right. We'll put, we'll run testing upgrades. This is the whole problem with this testing upgrades. I always come to this. What's this artifacts? But I think that instead of this artifacts with upgrade artifacts, I think with upgrade artifacts, let's go over here. Wait, what were we doing? Kinder build node image variant. These instructions are a little out of date because, like you can see here, it's build node image variant where it's just build node variant. Build node variant, and even under the usage, it still says node image variant. We should make a pull request to Kinder. We could clean up some of this stuff, especially the documentation. I feel like there's only a few people that use it anyways, and so they kind of know how to use it. All right, let's see. Here it says with upgrade artifacts, with init artifacts, with upgrade artifacts. So this says version build label path to folder with Kubernetes binaries. I think that we should be able to use this with, just like we're doing with these. So we should be able to pass the kindest node image, right? Maybe not. I don't know. Because it's hard to generate these image tarballs. And by hard, I mean, I don't know how yet. Nobody's shown me. So all I really want to do is test my k8s with what's already out there. Let's see if we can't hack these commands together. And then we'll move on to Rust. Because I want to have some fun today. So this seem to be fine. We have a 116 to 117 that was made by this command. Now we should be able to make a new variant with our k8s. But what doesn't make sense to me is if we make it with our k8s might stand up a 117 cluster, but it definitely won't stand up a 116 cluster. What do they do here again? Except an input version, a release, or CI build label. Okay, so we should be able to with that. Do you know what the easier way of testing this is? Is just making a pull request. Maybe that's what we should do instead of playing around with this. I wanted to test, we can make the test PR. I think that this is going to take a little bit of work, and maybe we will work on just making a PR to fix some of these things. So some of the misdocumentation. Because right now, I don't know how I would test, because technically my k8s version is for 118. I mean, because it's on master. Which I guess I could make a node image out of 118, because when we build a variant, we can give it what they're saying here. Let's look at the kinda reference. Maybe this will clear things up. I actually know somebody that works on Kinder, or Kind, not Kinder. Maybe I need to ask him to join me one of these times. Okay, yes. Kinder exec, got it. Copying, altering images. All right, altering images. A local folder, as shown in the examples above. Yeah, so what I don't get about the local folder, it sounds very easy. How do you make the local folder? That's all I need to know. So node image variant, build from the latest, building this with init artifacts of 114. Init artifacts will be placed in well-known folders, kind bin and kind images. So this is what we were doing with KubeADM. And yeah, this is what we were doing. We weren't using Bazel to build. That's why it's different. Okay, we're just gonna make a pull request. This is not worth it at this point. I need to sit down with somebody. I think there's two things I don't like. Every single time I run this, it destroys my stream. Hey, what's up? Daddy Robot, have you actually ever used Kinder or Kind to build a cluster? So it's very convenient to just easily build a cluster. What I'm trying to do is test an upgrade. So test KubeADM upgrading a cluster from one version to another. And so far, I have failed to do it. I get really close, but like, so what the problem with this one will be is I'll make this and then I'll override the KubeADM and then we'll use the wrong KubeADM version when standing up the 116. So within it artifacts 116 and we run on the 117 and we'll build this. And this is a great image. My next command here, if I'm going to do this, will be to build a node variant. One second, let me pull the help up. With the base image being the one I just made. So that would be the, let's just copy and paste. I don't accidentally screw that up. I screwed it up. I screwed it up. All right, so we build the node image or the node variant with the base image of this, and then we're going to add our own KubeADM artifacts here. So we'll do with KubeADM, and that's from home, Merrick, go, source, k8, Kubernetes, output, Dockerized, bin. Linux something KubeADM. So now we'll build this. But the problem with this is that this with KubeADM doesn't override the 117 part. It also overrides the 116, or at least that's been my... Oh, I'm sorry. I really like Docker. Do you not use Docker a whole lot? All right. Actually, and Docker Compose, I think, is a underrated dev tool. Docker Compose is. I I really like that. So at this point, we have this. Well, whatever. I didn't give it an image name, so let's give it an image name. We'll do it again, and we'll call this one best ever. So basically, we made this PR. So we've did a refactor of the Kubadium upgrade. So I work on Kubadium. It's an installer for Kubernetes, and we did a refactor, but I've never actually tested upgrade. I'm one of the newer people to the community. So we can look at our Docker images, and here's our best ever. And so now we can use that for kind, or kinder. And we want to kinder create cluster. I forget what. Yeah, so we want to do image. So anyways, I haven't had the pleasure of doing all this different testing. This is the test framework that's used. So our image is worker nodes. Let's do 2. Control plane nodes. Let's do 1. Default of 1 anyway. So, yeah, that's all we need to do. That's going to run for a second. I'm actually going to get a drink really quickly while that's happening. Oh, Docker? Yeah. Docker is nice. I like it. Container D. I work with a lot of the different technologies with containers. So, I do like Docker Compose though. If you haven't used Docker Compose, it will bring you to a whole nother level of understanding. So like Docker Compose is almost Kubernetes light. That's what it's like Kubernetes light. So basically Docker Compose is a way. Sweet. All right, and then there's our cluster. But Docker Compose is it starts tying stuff together. So, Kubernetes has its pods and its networks, and it's very complicated and has all of that stuff. Docker Compose is almost like just a singular pod in a Kubernetes orchestration. So, all right. Now we should be able to E2E test, right? I think that's all we have to do. Kinder test E2E. Actually, I think we don't have to do the E2E. Well, in theory, we shouldn't have to. Kinder. No. Kinder test help. I thought there was an upgrade test. Maybe it's just E2E. Nah, there's something special for upgrade. Okay, similar to ETA test, there's a suite of test aims checking that QA is created. Okay, test E2E QADM. This is what we want. I did it wrong. All right, now while this is running, I'm gonna run and get a drink. Fighting Docker. Well, let's do some Docker stuff. That's part of what this is. So bring your questions. I love to answer them. If there's some way that I can help, um, let's go over with it. Because Docker is confusing. Kubernetes adds just a whole nother confusing layer on top of it. They can really be powerful if you it's like this. Currently, Kinder is another technology on top of Kubernetes and Docker, and sometimes it's really confusing and like I'm feeling like I just fight it instead of actually use it. But generally, once you get around the rough edges, and Docker has improved a lot. But let's do some of the stuff. If there's especially if you have specific questions. Yeah. Having a reason is always useful. I always find a reason to use it, but yeah, I do need a drink. I'll be right back. We'll let this run. I'm glad I'm that soothing. So these tests will take a little while to run. We'll see how they go. Hopefully it goes well. I can try to talk in a more I don't know, that sounds creepy to me. Never mind. I won't do it. I have my limits. I don't have much of a radio voice, I don't think, but I do have a face for radio. I've been told that many a times. People like to compliment me. All right, so with that running, I'm gonna say hopefully done. We can get on to something more interesting. Actually, not necessarily more interesting. What's up, Easy James? How are you? While that runs, we'll switch over and start getting up to date with what we were doing in Rust 3 weeks ago. Really that long ago? Hear that it was. Nope. Finger muscle habits. Only Go has to exist in a specific folder. All right. So we were let's open up this tab here and we should look for I do not know what key combination I hit to do that. We were doing, what were we doing? Tungstenite async. All right. So basically, we did Tokyo async, and we got it working. And I'm not sure why we really want async, except that it's the new way to do it, and thus it's better. That would be my easiest way. I very much fall down that rabbit hole sometimes. It is better though. Hey, what are you doing on Kubernetes? There, if you don't mind me asking, are you using it or programming on it? Here, a lot of the times we're programming on Kubernetes. So, well, what I'm trying to do is I do contributions to upstream, and so I have commitments there. So sometimes it dominates my time. Trying to get the upstream or the Kubernetes work out. And then what I'm actually trying to do is write. You can get some information about it, or I have some information about it. But we're trying to write a interesting bot that is made to be run on Kubernetes, which is kind of an interesting thing. I actually think most Twitch bots, or this one will be able to do Twitch or pretty much everything except maybe YouTube. But Twitch, Discord, Mixer are some of the big targets. But I don't know that a lot of the bots are actually run on Kubernetes because they have an interesting problem where if you look here, we make a no, not here. But if you look in the chat client, this is actually a WebSocket. Yeah, this is. So WebSockets are really interesting because when you're talking about a stateful data set, it doesn't really mix with stateful data sets don't really mix with stateless. So it's providing us an interesting challenge here. We're going to build a chatbot. Well, we're also going to power this chatbot by AI and a bunch of other stuff, but we're also going to make it run on Kubernetes. So hopefully we'll do both sides of the box. We'll be developing an app to run natively inside of Kubernetes, as well as developing code for Kubernetes itself. Oh, you're preparing for the CCAD? I call it the CCAD. The other one would be CCA. But I'm actually preparing for both myself. I don't know how hard they're going to be because I deal with Kubernetes pretty much every single day. But I'm going to prepare for them. That's really cool. You should stick around then and join us. We'll do a whole bunch of different Kubernetes related stuff. Whether it's building an app for Kubernetes, which is part of it, and it was something that was interesting and I thought was relevant to a stream, or this is my job, kind of my job. It's my job-ish. My job doesn't require me to develop for upstream Kubernetes, but they like that I do. So yeah. We had an error. Let's see. Should be accessible for nodes. This is not. This is a config map issue. Why did it fail though on our cluster? So this doesn't look to be anything to do with what we were testing because ours is the upgrade and that this is a weird error. Let's see. Took 200 seconds. And it's in the Kubadium config map. Oh. I mean, I guess this could be maybe a cause from a bad upgrade. Let's wait and see. It could also just be because it's slow. Let's see. You should be allowed to post CSR from kubelet certificates on joining nodes. Oh, this almost looks like it didn't bootstrap properly. Let's see. Entering directory. Boom, 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 boom. I don't actually. Let's see what else it does, but I think I have a problem. I'll show you what I think. Let's go over here. Kinder. Can I get clusters? We have a kind cluster. Cube config path. All right, so let's two cube. That's what I'm worried. I don't know. We started to run the Kubadium test suite, but I don't know that we actually made a real cluster. Let's see. What else can we get? We can get artifacts, nodes. Let's do nodes. Kinder get nodes. We have the nodes, but again, I don't think that we actually ran anything to run stuff on them. So I think all of these tests are running against a dead cluster, would be my assumption. Because the thing that's making me think that is, one, all of these are timing out. And two, this is just seriously this is simple. This should not have failed. Even if we screwed something up with the... I think we can stop this. Yeah. And I think what we skipped was... So this is what we were doing, but I think we need to build... I think before we do that, we need to just exec... Is it kinder exec? No, I think there's a do. Where's do? Yeah, kinder do. Kubadium in it. I think this is what we need to do. That's fine, 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 fine. I don't know if that's fine. We'll find out. I do kind of like the bleeding edge of insanity. Sorry, I missed that comment, and it was a while ago. Kubernetes and Rust. It's like people that really hate their lives and then just want to make it slightly worse some way. Um, yeah. So it's quite possible I have some problems. Quite possible. All right. So once this goes, we should verify that we actually have a cluster before. So I think that we have to then do join after we did init because Cubadium has init and then there's join. So init will create the first control plane. So let's do this. Actually, okay, let's do this. Oh, this is localhost. I don't think it does run on local. Well, no, it does run on localhost. It would have to. All right, so now we can do Cubadium join. I was thinking that the E2E test would do all of this for me, but I guess it doesn't. So that's a little bit sad. I have contemplated that the fact that I picked Rust for the app that was going to run in our cluster was a little painful on me. So Rust is a language I really like the concept of. I'm not very good at it yet, so I can't say that I absolutely love it, but so far I've really liked the concept of. But I suck at it, so it's a good learning experience for me. All right, let's get back to that. That's not what I meant to do at all. All right, so this is our Twitch client. Twitch is the only one that I have working at this point. We can go ahead and look at all the fantastic mixer progress I have. Check it out. It's almost as impressive as all the Discord progress I have. These are quite impressive files. So, this uses something called Tokyo Tungstenite, Tokyo bindings for the Tungstenite WebSocket. And I really wanted to update it to the async because I thought that that would be cooler. Because also async is the bleeding edge, so Tokyo is kind of old school Rust. You know, it's like all of like 3 months ago we've moved on. We have moved on. All right. All right, so we have our cluster now. That looks good. Let's do the age of unknown is a little weird, but I think it's probably because it's a kind cluster. So we can see these are our nodes. So this one's the control plane and the workers. They're all running in this Docker. So I'm assuming that's why the component status is unknown. I don't know that I've ever actually looked at it in a kind cluster. So now we should be able to run these E2E tests. Wow, that went so much faster. Which 6 got skipped? This is hard to read. Highlighting it doesn't help. Oh, DNS add-on tests. Oh, this is like high availability. kubedns. Okay. Looks good. Awesome. So now we can make that pull request to Kubernetes, and that will be good. Let's. Since we did modify those, we should probably run just a few of the update scripts really quickly. These just make sure that your pull request doesn't fail for random reasons. Oh, see, Bazel needed updated. Let's see what it is. Oh, okay. So I do remember this. We actually deleted a import, and so if you delete an import from here, the Bazel build file needs to be updated. So let's pull up one of those. They have all of the builds. Go language is such a disaster as far as building and packages. And Google's insisting on using Bazel to build Go. All right, so let's run one last one. This could be the only other one with the little that we change. This just goes and updates your Go format. It's nice to run before you make it. Do I work with this software in real work life? I think, if I understand what you mean by that, yes. I do. Not kinder. Kinder, what we're playing around with right now is a way that Kubernetes uses to test, and I use Kinder to test a lot of stuff. But I don't chronically use it to test upgrading between versions of Kubernetes, which is what we were attempting to do today, which I think we kind of got to work. I have to verify that it actually upgraded to, but yes, I do. This is the Upstreams Kubernetes project. So my work life is around supporting what I call downstream Kubernetes. So I'm part of a team that helps support Kubernetes on the OpenSUSE platform. So it's a distribution of Linux, and so we deal with supporting Kubernetes on our Linux distribution, and part of that is building tools around it. And one of our tools uses kubeadm, and I also contribute to kubeadm, which is part of the Kubernetes project. This is there we go. We can make the actual pull request. If you guys actually want to see that, it's a pretty standard GitHub pull request. Yeah. All right. Oh. What is this not liking? What? I do not know how that got there. Did we just check that in? Because that would be hilarious. Not really hilarious, but okay. No, we didn't. We made that change later. Good. I was gonna say that's not hilarious at all. All right. So in not real work life, I work on this, which this is us trying to make a stateful app run in Kubernetes in a non-stateful way, or at least attempting to. At my current plan, we're gonna probably make the use of an operator. I'm thinking an operator, a Kubernetes operator, which will also be fun because we'll get to write a Kubernetes operator. I haven't decided whether we write the Kubernetes operator in Rust. That's if we're really hating life. It would be much easier to write in Go. But we could do it in Rust, especially if we're feeling adventurous or really not liking life at the time. All right, back to this async. So we have we were trying to go from, we probably won't get this all done today, but we were trying to go from the Tokyo Tungstenite to, and I know we shouldn't use star. Star's bad. Actually, I was showing Beams on Toast this the other day. A very cool Visual Studio Code plugin. If you're working on Rust, there is a cargo one, and it will tell you what it is. So we can actually go over here and we can see that our Tokyo Tungstenite latest version is 9.0. And if we actually write this, we can see that this is the latest async tungstenite. It's probably best not to use the stars. We'll update all of these to be good citizens. All right. And this also means that this is behind. That's why it's giving us a latest and not a thumbs up. Unfortunately, that plugin does not work for Vim. All right. So I'm going to have to take a little while. I was out for a couple of weeks. And I have got to just think about it for a second. Actually, let's look at the documentation here. It should be really close, I think. Let's see, async. We still want to use it with Tokyo, or we could just leave it with Tokyo. It doesn't use async and await, which is kind of the cool new thing. I'm not quite sure what they're trying to demonstrate here. I was hoping for a few more comments. They're making a TLS stream, which we don't actually have to worry about. Maybe we don't want to worry about this. Maybe we can do this refactor a little bit later. Because it does work how it is. Or let's run it and make sure it's still working. This might work. Yes. I don't know. I was fiddling around with it, so I might have accidentally changed something. It's doing a whole rebuild. All right. Oh, it's going to because I added a new package. I'm gonna say usually it doesn't do such a whole long rebuild. So, Carols, what do you do in your real work life? I do some amalgamation of this over here. Actually, I can show you what my company does, since OpenSUSE is it's an open source company. So let's see. This is the product that uses Kubernetes. So it helps manage Kubernetes clusters. So, yep. You can check it out. Oh, look, check it out. What's up, Twitch? All right, so only those in Twitch can actually see that this worked. And actually, it will send me. It also gets the stuff back, so it's working. So maybe we should just leave it for the time being. I think the reason I had wanted to switch was async and await was going to make it easier to send messages back and forth. So basically, one of the next goals is to add uh, basic commands. Oh, cool. Well, you will probably like some of what we do here, because we do a lot of Kubernetes work. I'm wanting to try to get more of what I do on a daily basis on stream because it's mostly open source. The hard part about it is not that I necessarily do anything that can't be on stream, except that I do a decent amount of meetings, which I don't know. I would like to get away from doing, but at the moment I do a decent number of meetings, and so that makes doing my work on stream hard because, yeah, I have a team to support. So, yeah. But I have a couple things coming up. In February, I have a whole week where I'm just going to I get a week to do a project. And so that's probably going to be 24/7 on stream, because I'm going to be doing some project with Kubernetes. And yeah. So, yep, I do what I can on stream. And so when I'm doing upstream Kubernetes work, I try to do that. That's mostly Tuesdays and Thursdays. In the afternoons, when I'm done with work, like right now, I will switch over to doing this, which is an app to run on Kubernetes. So there's a couple reasons to do this. One, it's making a native framework for chat clients to run natively in Kubernetes. But another is I want to learn Rust, because I really like the concept. So I now need to explore the language to see how much better I like it. As well as another thing I want to do on stream is actually build, support, and maintain a Kubernetes cluster. And I kind of need something to run in it. I can't just build and support a cluster that doesn't actually run anything. That's against my. So I've got to have something that's useful. So I got to build something that's useful in it. So, anyways, that's my. So I think we're just going to leave it with Tokyo for the time being. Do I consider myself a dev or an admin ops? I think that I live somewhere in the middle. I would probably say at this point I'm not good at either one. Like I'm now not an expert on either one. I'm kind of decent at both, and I kind of do both. So I do a lot of dev work for admin ops. So, yeah, that's kind of what I do. So, which code for admin ops I find to be a lot dirtier and nastier. So that's why I say I'm not as good at it anymore. Because so when I used to lead a team that actually made applications for people to use, and we were a little bit more um, pragmatic programmers. Whereas when you get into admin ops, you get into this nasty situation where there's really no good way of doing it. And I find that I get into that way more doing Linux admin stuff than I did when it was just a pure web service. So I don't know. Yeah, I don't know. All right, so let's go back to here where we sent a message. All right, and this worked. So this is good. Now, what we wanted to do is set up a way to read and respond. So this thread can send a message. It owns this. We need to have something that reads the messages. That's what we were working on. And this is why we were thinking about the async and wait might be simpler because it cleans up the syntax some. Although we're going to have to learn about async and await before I do that. So before I do that on stream, I have to go and actually learn how to use Rust's async and await. If Beams on Toast was here, he would tell us. Because we need to then update this to do it. We have this sender here that we can use. Let's see. That sender can be used here. When we receive a message, I don't remember where that was. Okay, so here is wait for the futures to complete. And this is where we're basically just forwarding to the sync. That's why it prints out the new messages. Well, so I would be a terrible person if I didn't use OpenSUSE, since that's kind of who I work for. So there. Now, if you're talking about tumbleweed versus leap, I kind of have a saying that there is only troubleweed and leap. So use troubleweed or leap. Either one's great. Tumbleweed, you need to be careful when updating it. Be careful when you update Tumbleweed. It's a really great concept. It's a rolling release for a distro, and it's generally really nice. If I have a VM running it currently, I actually run Tumbleweed in a VM because it allows me to take snapshots, and you can actually run it with Btrfs and keep snapshots so that it's not as devastating if it messes up. Leap is really stable, but its packages are really far behind, so it's kind of a trade-off. Tumbleweed is cutting edge, a little unstable. Leap is really stable, but a little behind. If you don't want to use those, you can also use Ubuntu. That is what that's what this desktop is. Now, that's not what this is in. This is SSH'd because I do most of my work on a server. But this desktop is Ubuntu. You use whatever you want. They're all kind of the same. It's almost basically your package manager and how often they deliver new packages. Some on the little bit on the kernel. I use mostly Ubuntu and OpenSUSE. So Ubuntu is really nice because everything works for it. So my desktop environment is Ubuntu. This is just a background image because that's who I work for. And so I like giving them credit. But it is Ubuntu. It's just not the default launcher. This launcher is I use i3. So I use i3. It's not the Unity or whatever. They just do GNOME now, don't they? So it's not GNOME, but I used to run off of GNOME. But GNOME has a problem with the compositors when streaming. So you'll get a lot of flashy crap when you're here with the compositors because I guess they're doing a bunch of fancy stuff and OBS has a hard time capturing. So then I switched to IBS and I really, or not IBS, i3, and I've actually really liked i3. Man, it's so easy to get me sidetracked. Let me really quickly. So the entire desktop becomes configurable from a text file, which is actually, it's a lot to take in at first, but it's actually really nice. If you notice up here, my different these are my different workspaces are all defined here. So even their names, like the second one is code. It's all configurable. It's pretty nice. But yes, then I SSH into this box. And this is also a Ubuntu box. So let's see. Let's open up here and I can show you the tumbleweed box. Yeah, the upper corner is pretty nice. I haven't configured it completely, but I did configure this. So it's all configurable. Yeah. Anyways, so this is my. I don't want to open here, but this is my tumbleweed box, or no, this is my leap box, and this is my this is my tumbleweed box. So, and then we can SSH into them. They don't have UIs. I don't think I actually. So on Tuesdays, I'm doing Kubernetes the hard way. Um, and I'm actually updating my YouTube channel. I'm cutting them up and doing them nice for YouTube. So if you guys have ever heard of Kelsey Hightower's Kubernetes the hard way, I'm doing this except through KVM. So we're going through and building a Kubernetes cluster with no tools. Well, not no tools, but no automation tools. Where we'll be more like right about here. But I'm also making individual YouTube videos, so seems like a lot of you guys are interested in Kubernetes. So you should join for that. It's fun, very educational. It's helped me a lot. All right, so let's get back to this. We need to, instead of just forwarding these to the sink. Wait, sync is the stream of message. Stream is the incoming messages. So we want to take this stream, and here, every time we get a message, we're just waiting. Wait. No, this does not make sense. Okay, so for stream, for each message, what do we do with message? Okay, yeah, we're just printing a 0. Let's run this and verify, but we're just printing a message with the. That's excellent. And so what we need to do is redirect them to another thread that's going to process the message and or respond to it if it's a command. I absolutely can put a link. Sorry, I didn't think about that. Once we finish the bot and it actually runs, will have all these under command. So, but I don't right now. So this is the Kubernetes the hardest way, or the hard way, is right there. And then, yeah. Absolutely. Yeah, it's this guy has done a great amount of work on this, and it's pretty fantastic. You should never actually set up a cluster this way, but if you're wanting to understand how a cluster operates altogether, it's fantastic. All right, so we need to understand exactly what's going on in here. All right. Before it, all messages composed out of the data entered to the ST to the sink. All right, so this is where they're forwarding the ST. Okay, we don't actually want to do this because we're not going to be typing in. The bot should respond on its own. And then this is where we send the message. I'm kind of surprised this works. This is kind of a mess. So we take this sender and we send a message. That sender is linked to this sender. With this message. And this message uses this sender to actually send the message. which is from this message send. So here is where we have our two-way communication, but I'm not sure we actually are using it properly yet. This is where we connect to the WebSocket. We should have a peer address. Okay. And this is where we get to the Tokyo part and we run it. All right, and then we're saving it to a object, which then we can return. All right, let's go up here. I am about to have to get going. I'm hopefully going to stream this weekend on Saturday. That was kind of my plan for this year, is to add Saturdays mornings. I am, yeah, and then I'll actually have read up on the async, and we'll cover exactly how async is going to help us here. So async is going to, I think, help us clear up our main loop here. So on main, basically what we want to do is here we can use this Twitch client to send stuff, but we also want to receive stuff and handle that. And we're going to have to spin up another thread to loop over it. Or at first we could loop over it here on the main thread because it's not doing anything else. The other thing that we need to think about is how we handle channels. So in theory, this one client could be listening on multiple people's threads. So I need to think about this for a day or two, because this one client could be listening on multiple clients. So I think the proper answer is a green thread per channel. You don't want a real thread per channel because you'd run out of threads too quickly if there was like 100 or so. And so I have to catch up on this stuff because, again, it's been like 3 weeks. I was out of the country for a little while, so sorry I wasn't streaming there for a little while. Next Tuesday, we're going to be doing Kubernetes the hard way. So definitely come back for that. And we'll be still working on this whenever the time permits itself. So I'm gonna head and get going. Thank you guys for joining me. It was a pleasure. And I will we'll get this worked out on Saturday. I'm pretty tired. I'm still kind of jet lagged. Flying back from Taiwan has been the worst jet lag experience of my life. I am super dragging. But yeah, thanks for hanging out, and I look forward to doing more stuff with you guys. Thank you. I'll see you guys later.